For this example, let's take a look at rational functions. Specifically, can we make a rational function that has two vertical asymptotes and one oblique asymptote? Well, in order to do that, let us review asymptotes real quickly. Vertical asymptotes arise if we have factors, reduced factors, in denominator. So we have to have at least a quadratic polynomial in the denominator to give us two zeros, which give us 0 in the denominator. And in order to have an oblique asymptote, we need to have a degree 1 degree higher in the numerator than in denominator. So what can we do? Well, looks like we need to have quadratic polynomial in denominator in order to give us two zeros. So something that can factor to give us two zeros. So for example, x squared minus 5x plus 6. That's just to name one example. So anything that can be factored to give us two zeros would do. So we need to have 1 degree higher in the numerator in order to have an oblique asymptote, which means slanted by definition. So we need a cubic polynomial, 1 degree higher. So how about we'll have x cubed plus x plus 1. Or any cubic polynomial would have done, but here we're just making an example. So what would be the asymptotes? Well, in order to find vertical asymptotes, the a for short, we can set the denominator equal to 0. So all we need to do is to be able to factor it, which factors as x minus 3, x minus 2. So we have two zeros, which give us two vertical asymptotes, namely x equals to 3 and x equals to 2. So these are our vertical asymptotes right here. So how do we find oblique asymptote? Notice we cannot perform synthetic division because this is not a linear polynomial in denominator. So what can we do? Well, we can do long division, and let us be able to set it up as a long division problem to find oblique. So we don't have any horizontal asymptotes in this case, none, but we do have oblique. And how do we find it? Let's set it up as a long division. So what if we have x squared minus 5x plus 6? That's what we're dividing by, so that's on the outside. And on the inside we have x cubed. Notice x squared is missing, so we have to fill it in with 0x squared, and then plus x plus 1. So how do we perform long division? We take x squared right here, the leading term, and make it go into x cubed. Well, that goes x times. Now let's distribute the x back into this polynomial. So we're going to have x cubed, then x minus times negative 5x will give us minus 5x squared. Then x times 6 is going to give us plus 6x. What we want to do is subtract. Notice x cubes will cancel, but we need to change sign because we do distribute the negative. So we'll have 0 plus 5x squared. We just need to remember to change the sign. So we'll get positive 5x squared. We change the sign here. So it will be x minus 6x, which is going to give us minus 5x. And the 1 simply comes down. So it would be plus 1. We need to repeat the step because x squared can go into 5x squared 5 times. So we have one more factor. Again, we distribute just the 5 now back to this polynomial. So we're going to have minus 5x squared. Then 5 times negative 5x is going to give us minus 25x. And then 5 times 6 is going to give us plus 30. Again, we need to subtract. 5x squared will cancel again. Cross it out. Again, we need to switch this negative down. So we'll have negative 5x plus 25x. Let me scroll down a little bit. So we're going to have positive 20x. And Here we switch positive into a minus sign, so it would be 1 minus 30, which gives us minus 29. Now notice x squared cannot go into 20x because the degree is not high enough. So what we have here is the remainder. However, with oblique asymptotes, the remainder does not play a role. Why? Because when x is big, the remainder is going to be divided by this function right here, and so that'll actually go to 0. So really all we have for the oblique asymptote is y equals to the answer, which is x plus 5. And here we have our oblique asymptote. Now to be able to graph it, for example, we would graph this asymptote just as we would with linear functions with a slope and y-intercept. We would graph both of these vertical asymptotes, and then we need to plot some points in the original function or find intercepts, for example, to be able to graph it. I would probably use graphing calculator to graph this one, but some simpler ones we can take a look in the next section. We can graph them. And that concludes this video.